Hello everyone, I'm HALİL and these are my good friends, BUSE, FATİH and HALİL. Today we are going to introduce our end-to-end encrypted chat application called as FATİH. I want to start presentation with outline. We will start with organization sheet, then our roles, tools, and software used in project, and continue like that. Our organization sheet, our advisor is Gürcü. We work as a team and we help each other in every section. Like one is work in front-end parts, back-end parts also help the front-end part, and front-end part also help the back-end part. And what is our goal? Our goal is make app with enhanced security and privacy, user-friendly experience, and enhanced chat options, including our project.
Hello, this is SARUHAN, and I'm going to explain which tools and softwares and libraries we use in this project. Firstly, we used MongoDB technology to set up our database structure, and we use White.js is a build tool and development server for web applications. And Node.js is used for runtime environment based on JavaScript. We used GitHub for the version control system. Our team leader created a main repository and separated forms for each group member. So we ensure that if we had a problem on current control, current version, we could turn back to the previous one easily. And for the clients and front-end development, we use React.js and also UI development. Mongoose is used for just the setup connection between server and Mongo database. And NodeMail is used for the send user to verification email to verify it's exactly as this email. And Moonturn is used for the multimedia file management. And Socket.io is provided us the message service. And Express.js is used for the backend development. And for the encryption algorithms, we use Crypto.js library.
This one is used to only the hash or passwords, and also in another function it uses predefined key with a random key, and they combine each other. And in the end, there's an output of another random key, which is even stronger, and that key is used in our AES algorithm. 256 is the length of the keys used in our algorithm, and CDC stands for cycle blockchaining. What it does is, as you know, AES encrypts all the input text in blocks. So in CDC mode, each block of plain text is combined with the previous ciphertext. So it increases the randomness, also the strength of encryption. Now we will go to the design phase. Here we will show you the diagrams that we draw in our design phase. The first one is idle design. So as you can see, we have two different modules, stateless and stateful. In the stateless module, it's basically the interface or the platform requires to access all the other services. So the user sends HTTP request to a component called load balancer, and what load balancer does is it redirects all these requests to according services, so it distributes it more evenly and increases the availability of our server. So we have the service discovery, authentication service, and group management. All of them are like sub-based module. And in the stateful module, it is basically where the messaging is handled. So we have different users connected to the chat service with WebSocket or with socket IoT programming. And through those connections, the real-time chat is
this diagram representing the general system architecture. We have user 1 and user 2 that they are clients interacting with messaging service. API gateway acts as an entry point for all clients and requests, and it manages and routes requests from user to relevant endpoints. Server handles the message processing, manages connections, and communicate with other backend services. Relay service receives message from server and stores them into the database. And group service handles the management and creation of user group and store group information appropriately. Session service tracks users' online status and identifies who is connected and who is disconnected. Access service manages all multimedia requests from clients. In our project, as I mentioned previously, we used Multi library as an access service.
Next, we have the sequence diagram. This diagram shows the sequence of events in one function. For example, we have two actors here, user and group admin, which is also a user. We will talk about it later in the use case diagram. So when a user logs in, if the login is successful, he will have the access to the chat service. So whenever he wants to send a message, he can choose a chat, whether it's a group or another person. From the list, he selects that chat, and when he sends a message, the database is updated with the message he sent, and also the chat story will be updated and seen in the user interface. Also, the user is able to create a group chat or select an existing group chat if he wants to send a message. When the same sequence is happening, when we send a chat message in the group chat, again the database will be updated but in a different table, and then also the chat story will be updated as well in the user interface. He also has the option to leave the group chat. It's the same sequence in the send message and receive message, but it's all the way around. Again, when he receives a message, he doesn't do anything, but the database fetches the new message and the UI is updated on the chat screen. And also when upon receiving a new message, the notification is sent to the user as well. We will cover more of this in our demonstration. In activity diagram, we first check if the user of the system is actually a user saved in the system. If not, he will be redirected to the registration screen. If he is registered, he will log in, and then we will check if his credentials are correct. If not, he has to retry again, whether it's a wrong password or wrong username. And once the user is validated, he will be directed to the home page. And in the home page, we have the navigation bar from where the user can access multiple functions. He can view the profile page where his information are listed. He can simply log out, which is an endpoint. And last but not least, he can reach the chat page where he can choose either a user or a group to send a message into. Or he can just create a group from the same screen. This will be for the diagram.
And this entity relationship diagram illustrates our messaging application structure. K entities includes group chats, group chat messages, and notifications, conversations, tokens, and users. Users can send and receive message belong to a group, receives notifications, tokens verify users, and conversations track interaction between participants, and group chat message stores group message separately. And this is the physical database table. This is the same, exactly the same as the VR diagram without exclude the visual relation of diamonds.
Now, as I said before, we have a use case diagram. This one just displays the functional requirements of our project. We have two admin, user and group admin. Group chat admin is basically a user, so it has all the abilities which a regular user has, but additionally it has the abilities to add a user to a group, remove the user from a group, or delete the group altogether. Other than that, all users have access to registration, login, logout, sending a message, sending video or audio, as well as other Wi-Fi. They can create or leave a group chat. Group chat messaging is also there, and they can view the online status of others. And this is the context diagram, also known as the level 0 protocol diagram. It basically shows the directions that data travels through. For example, from user, we have the send message going to the server, where that message will be encrypted, and there's a bidirectional arrow between the database and server. So all the data transfer between database and server will be in encrypted form, and encryption and decryption are made in the server. So when a user receives a message from the server, it will be decrypted. And also, user can send a request to create a group, and once that group is created, he will be the admin of that group. So he can send other requests such as adding or removing the users to that group.
At the beginning of the project, we taught how to send message securely, and we found four main solutions about that. First one is encryption techniques, second one security testing and evaluation, and data storage and privacy. And the last one is key management. In encryption technique, we use asymmetric bias encryption. In key management, we also use key generation, key renewal, key storage and distribution. Also, we made vulnerability scanning, code analysis, and penetration testing. In data storage and privacy, we made metadata privacy and encrypted message storage, and also message expiry time, dates, and deletion.
Hello, I'm YÜKSEL, and as my team leader said, the name of our project is FATİH. It comes from Fortify and Fortress. Like many other projects, FATİH also has strengths, weaknesses, opportunities, and threats. Our strength is the encryption system. It allows us to gain users' trust. But besides being secure, the encryption and decryption features may consume more computational resources, so this is our weakness. For opportunities, FATİH, because of the reliability, FATİH can be an example in society, so it can provide some opportunities for future other projects. The threats of our project is that it may allow some illegal events, like because we cannot read the messages in that database. So it is like if I am the illegal guy, it will be easy for me to talk my illegal friends illegally. So this was our presentation. If you don't have any questions, we would like to go to the discussion.
he or she not have an account needs to be registered. Also, we made error handling here. Username must be unique and password must be 6 digits. As you can see, password do not match. It must be 6 digits. We need to confirm the verification for the login. We can, if we don't have email in our email, we can resend the link and confirm it. As you can see, email verification mail came and it's a verification page. It shows the email verified or not.
Yes. When you log into your new account, the first thing you will see is the home page. And the navigation bar at the bottom of the screen. With this navigation bar, you can visit other pages. You can go to profile page. For now, this project is not fully developed, so you cannot change your user information, but it can be improved. You can visit chat page. In here, as you can see, on the left-hand side, there's a sidebar, and you can search by scrolling the sidebar, or you can search with this search bar. And also you can type. And for example, I want to speak with my friend. She is online right now. I don't know if you can see, but the bubble is green right now. It means she's online. And I will text her. I text her, and I can choose a file to send her by clicking here. And this file can be any type. There is no restriction. As you can see, I sent an image to her. And as you can see at the bottom of the screen in the navigation bar, there is an additional icon here named as Create Group. to remove members by selecting here, and I have the ability to add members and delete group. If I am not the admin, my friend will create a group. And also, when the other members of the group send a message, you will see the names who sent the message or the time when they. Okay. For this group, I am not the admin, so I cannot see remove, add, or delete group buttons. So I just can leave the group. As you can see here, there's the name, who sent it, and the time. And when I'm offline or I'm talking with somebody else, and someone can message me. When someone messages me, there will be a ring at the top of the screen. When I click this, I will see who sent it. And if I don't want to read it, I can just click to trash, or if I want to reply it, I can go to that. I can click it and I can go to that chat. And also with this icon, I can go out. That was it. Thank you for listening. We are ready for it.
I have a question. Yes, so you have a diagram for database figures 12, 13 in the report. Yes, and it is not mentioned secret key.
Yes.
Yes. So how you cope with the secret key? So is it not stored in the database? If not in the database, where is it? Yes. So how key exchange is made? And so what about the secret? I expect your database right to find.
In the diagram, we don't show the exact encryption process, it just shows the direction that data travels. But for the encryption, first we have a predefined key, as an environmental variable, and other than that, we also create random keys for each encryption process, and then they combine with each other and create the actual key to be used in CDS.
The environmental variable, what does it mean, where it is stored?
It's stored in the project, and it can only be reached by the persons who have the source code to the project.
It's on the server side, not the client side, or a database.
So if you don't have...
Okay, so it is accessible only by a programmer,
Yes.
by the web.
Yes, if only has the files to the program.
So thus it is defined in the time of writing your source code. Yes, around time it can't be changed.
Actually, it can
That one does not change, but we don't use that code, that secret key alone. We have that one, which is like the same all the time, but every time we want to encrypt something, we first use that one and randomly generated another key, which is 16 bytes, and we combine them with each other, and then another key is generated through that combination. That one is the key that we use in each encryption.
Is it somewhere explained in the report? keys are key issue, very important issue.
We try to combine keys to make it more secure. So,
Yes, but
This ones are secret. This one is just by default, just in case there's a problem and we can't reach the environment variable. So we use this one, and then in the script sync function, we use that secret key and a randomly generated salt. And 32 here means that we apply this salt function 32 times. So the more that number is, the more secure it will be, but it will also consume more resources, so it's not practically good to choose a bigger number. So once that we create this key variable, then this is the part where we encrypt our data. So we have the initialization vector, which is also created randomly, and then we use AES-256 CDC. We use the key that we just generated, and then we use the initialization vector. That's all.
okay. Is it explained in the report?
Actually, it's in the appendix part.
In appendix one?
We have the sound close posted there.
Yes, for secure chart, yes, this management of keys is important. Since it is secure chart, yes, secrecy, security matters, yes, and this issue should be discussed as one of the main issues. So, key generation, key exchange, protection of keys.
Actually, in the implementation section in the report, I explained how the key generation
On which page of the report?
in 43 and 44.
43.
We have the pseudocodes, but they are not the exact implementation shown here, because we use the functions from a library to write them ourselves.
43, yes, there is pseudocode for script function. Yes. So this script function takes salt as we have seen in the code. Yes.
The parameters aren't exactly the same, because like I said, that's a
Yes,
pseudocode, just a
and
basic.
in outputs secret key. Yes, because I understand this script function. Okay, salt, what does it mean, salt?
You will need hash or price.
I mean that you
Random.
write in salt, and what is the meaning of salt? Yes, so what is it?
It's
What
a,
is
it's a
salt?
sequence of bytes generated randomly as well, so we don't know what salt is used for in encryption.
It is some bit string, how many bits or bytes, or it is constant, or is it time declared? What is this salt?
It's actually it should be bits and it's randomly generated by each time we ran or send a message. But in our password section, we also use salt, but not as same as this one.
Yes, if you use something randomly generated, yes, and if you have two communicated parties, okay, is it there this random generated one side, it is runtime generated. Yes, in runtime, one party may have one sequence of random numbers generated. generated, other party may have other. Okay, so if your random number generators are not synchronized, okay, if they produce different sequences of numbers, okay, you will get different secret keys. Okay,
But the AES is symmetric, so
yes, it is symmetric. Yes,
Yes,
so it needs that.
So for decryption,
yes.
for decryption we do not generate another key.
Yes, but these are remote parties. They are not staying on one computer. Yes, this say one party in Cyprus, other party in Britain. Yes, they use different computers, different environment, random number generators.
All the encryption part of decryption part is in the same place because our project located in server encryption and decryption part not on client side.
So that's from client to server message travels as open and open.
Yes,
While travel in an open can be viewed, so that's what is the use of such encryption decryption. So this encryption decryption shall be made by clients.
if made like that, also it can be accessed by the client side.
So issue is that security can suffer confidentiality when messages travel in the channels. If all encryption decryption is made locally in the server, it's not protecting messages, so our chat is maybe viewed.
Actually, we are more focused on the protected data in the database because nothing is stored in the database as plain text. Everything is.
Yes, I see, but the main issue of chat, secure chat, is that while traveling, messages travel hidden, closed, okay, encrypted, ciphertext travel, okay, so thus hackers, eavesdroppers can't understand what is going. Okay. If it travels in open to the server, while traveling they are read out, everything understandable, no value, no use of keeping of encrypted on the server, encrypted, so thus it is, we see that messages are not protected from reading. So confidentiality is not.
Protect.
Please explain the system to us. We have domain user, server, we have database. Just explain the relation and how they are performing communication with us.
Actually, as I said, our message not encrypted in client side. It's encrypted in server side, then goes to database. As you said, yeah, maybe be a real problem if malicious person in here change message or get
No
message.
change, encryption is from no alteration, not from alteration, it's from unauthorized reading. Reading is the first issue, security, confidentiality. Okay. So thus, since server maybe in America, yes, client in Cyprus, other client in the United Kingdom, yes, so while traveling through this Atlantic Ocean, cables maybe viewed, okay, so thus, where is this encryption?
Actually,
Encryption
there's a slight
should be before sending.
The thing is, the message is encrypted in the backhand side. I mean, by client we actually meant what user does with the input interface, but actually it's done in the backhand side. So actually, this part, I mean, the exchange is correct. The exchange between server and database is encrypted, but the thing is the encryption process
concerning this context diagram, what context diagram is? So it shall show system, its border, okay, with one, okay, and external actor systems, whatever else. Okay, so could you show border of the system? I do not see. Where is your system? Yes. How you show your system and what is external? Okay, so context diagram shows system in the environment. Okay, we have system, some box or circle or whatever else with well-defined borders, boundaries. Okay, where are the boundaries of your system? What is inside your system? What is outside your system? Could you show as a finger or just telling where is your system? Or by color it is specified?
And I think in this one, we didn't show the entire system. We just wanted to show the direction of
the question more particular. Is database a part of your system or it is external?
It's actually external. We use
External.
It's connected to that database.
So thus the database is already existing. If it is already existing, why you show a R diagram, physical diagram as a product of your. So if it is already existing, it shall not be shown as a part of your view. If it is part of your view, it shall be part of your system.
The system is the server actually, but we want to show that what is the relations between our system.
Yes, if your system is just a server, then database is outside. Yes, if it is outside, then it shall not be shown as your result. You show two figures, figure 12, the R diagram, 13, physical diagram. Yes, and you mentioned that they are identical, but in figure 12, users have not gender. In figure 13, there is gender users. Yes. So,
There's no another program for clients, right? Users are just terminals or
Yes, they just access to the
actually, it's explained. There is no two programs here. So the client side, there is no program.
Yes, the server is where we deploy the program. I mean, it's when you type the link of the website, that's the server. If we didn't deploy it to the server, we could just use our computers as servers, but no one outside from our
So going into the server,
center couldn't be able to reach it.
Actually, we upload the project to a server, the web service. Server is running here and we can access by link, all other persons can access by link, then can use it.
yes, but by link is very high level. So what communication you use? Socket? Socket.
Yes.
And if socket, it means remote communication. So thus there should be client running one program and server listening for clients. So there should be at least two programs. Okay. If you use socket programming, socket means that these channels are established for communication. Yes, and while traveling, this messages should be complete. Otherwise, it's something looking like, but not actually, not real, not providing real security.
But if you want, I can show the encrypted messages or
Yes, I understand. And in your report in the outline, there are some introduction to project, then B11, B12 up to B16 without any explanation. What is the rules?
Those are actually tables from the template. And
Yes, the template shall be filled. Yes, you shall fill by your particular information. If you have nothing to say, just remove it. There shall not be B11, just B11. Yes, similar B31, B32. Yes, so next looks filled. Yes, but in the outline, empty paragraphs, yes, looks very unpleasant. Yes, so templates are given to you to fill what you need and to remove these hints. Yes, if there is something, it shall be written, but here
tables are
Let's check green part.
I see. So that it is 8-1. Yes, but the name without, so number without name is meaningless. And it was to be cancelled. Yes, or name, this group, team members, this distribution of your package, because if we have B11 and nothing forward, yes, so then do not include it in the PowerPoint. Okay. So that's some agreement. Okay. I don't know.
The encryption was built on the client side for it to be end-to-end. You need to have on the client you can generate the random key also, and then the communication will be encrypted to the server. And you also encrypt the communication server to database separately. So that's the only way to be end-to-end.
But
The client is sending you.
if we encrypt in client side, we need to store the key in a database or another place.
You can store it on the client's device, the local storage.
But it can be also accessed by another person.
No, you have to make sure that the user and the local storage of the device or the device ID is same. And when the user logs out, you remove, right? And the hacker cannot get the local storage, but you can get the message in the network. So, and what's your name? Again, you said you were using the load balancer and the API gateway. How do you implement that in your code?
actually, we did not do it how we do it specifically when those we were referring to the project propositions from our advisors, and that's they had a link in that proposition, and that's how this pilot design was explained. So overall, that was done in kind of automatically. We didn't implement it
You
in
did
our
not implement the load balancer.
Yes. That was the general design explanation in that reference.
Yes.
So for our graduation project, we wanted to create this encrypted chat system, and we want people to be able to send each other, whether it's text or different file types. We want them to exchange that in a secure way. So all of us got together, and this was a very good experience for us, whether it's about the teamwork or try to build on this experience in our future careers.